Look up at the night sky. Everything you can see is only a tiny sliver of what's really there. This is the ultimate cosmic showdown, and the answer is stranger than you think. To understand this fight, we first have to meet the two contenders. Contender 1 is a star so big it breaks the imagination. Its name is Stephenson 218, a red supergiant buried deep in our own galaxy. It sits about 19,000 light-years away, in the direction of the constellation Scutum. Our Sun is already 1,000,000 times bigger than Earth. This star makes the Sun look like a speck. Stephenson 218 is about 2,150 times wider than the Sun. If we dropped it where the Sun is, it would swallow Mercury, Venus, Earth, Mars, Jupiter, and reach out towards Saturn. A beam of light, the fastest thing in the universe, would need about 9 hours just to travel around it once. You could pour about 10 billion suns into its volume and still have room to spare. But here is the twist. This giant is puffy and thin, more like a vast glowing cloud than a solid ball. For all its size, it holds only a few dozen times the mass of the Sun. It is enormous, but shockingly lightweight for something so huge. Inside, it is fusing heavier and heavier elements in a desperate, dying blaze. Stars this big live fast and die young, burning through their fuel in just a few million years. One day it will explode as a supernova, briefly outshining an entire galaxy. So our first fighter is the undisputed champion of sheer size. Now let's meet its opponent, and it plays by completely different rules. Contender 2 is not made of light at all. It is made of darkness. Its name is TON 618, and it is the heavyweight king of black holes. It lives more than 10 billion light-years away, so we see it as it was in the young universe. TN 618 weighs about 66 billion times the mass of our Sun. Try to picture 66 billion suns crushed into a single point. It is almost impossible. A black hole's size is measured by its event horizon, the point of no return. Cross that boundary, and not even light is fast enough to ever escape again. The event horizon of TON 618 is monstrous, wider than our entire solar system many times over. Its radius stretches about 1,300 times the distance from the Earth to the Sun. Light itself would need weeks just to cross from one side of it to the other. And TON 618 is not quiet. It is a quasar, one of the brightest objects in all of existence. Gas spirals in, heats to millions of degrees, and blazes before it falls into the dust. This single-feeding black hole can shine brighter than 100 entire galaxies combined. It fires jets of plasma across space at nearly the speed of light. So our second fighter is the undisputed champion of mass and raw power. Two very different giants. Now let's compare them round by round. Round 1 size. Which one is physically wider? Even the biggest star is tiny next to that event horizon. The black hole is more than 100 times wider. Round 1 goes to TON 618. Round 2, mass. Which one actually weighs more? This is not even close. The star is a few dozen suns, the black hole is 66 billion. The black hole is more than 1 billion times heavier. Round 2, another crushing win. Round 3, power. Which one pours out more energy? The star shines like hundreds of thousands of suns, which sounds incredible. But the quasar shines like 100 trillion suns. The star cannot compete. Round 3 goes to the black hole. It is now leading 3-0. But rounds on a scorecard are one thing. What if they actually met? Imagine the largest star drifting slowly toward the largest black hole. Long before they touch, the black hole's gravity starts to stretch the star. The near side is pulled far harder than the far side. Astronomers call this a tidal force. The star is ripped into a glowing ribbon of gas, a process nicknamed. That shredded star spirals in and joins the black hole's blazing disk of doom. As it falls, it flares brilliantly, a final scream of light before the darkness. And then it is gone. The star becomes just a little more mass for the monster. In a real encounter, the black hole does not just win, it eats its opponent whole. So on every measure that matters in a fight, the black hole is the undisputed champion. But wait, before we crown it, let's ask what winning really means here. The black hole is bigger, heavier, and more powerful, yet it only destroys. The star, by contrast, is a factory. It forges the very atoms that make planets and life. When it dies, it scatters those atoms to build new worlds. You are made of old stars. And that giant black hole, its enormous size, is almost entirely empty space. All that mass is crushed into an unimaginably tiny point called a singularity. So the star is a real, glowing, physical thing. The black hole is mostly a boundary around nothing. So who really wins depends entirely on what question you are asking. If it is a fight, the black hole wins without breaking a sweat. But if it is about creating, giving light, and making life possible, the star wins. The universe does not need just one kind of giant. It needs both. Giant black holes anchor galaxies and shape how they grow over billions of years. Giant stars light those galaxies up and fill them with the ingredients of life. Destroyer and creator, working together to build the cosmos we live in. And remember, these are our current record holders, measured across almost unimaginable distances. Tomorrow, a new telescope could find something even bigger and rewrite the whole contest. Next to either of these titans, our whole world is smaller than a grain of sand. And yet here we are, small enough to fit on a pixel, clever enough to weigh a black hole. If you enjoyed this cosmic showdown, subscribe, because the universe has endless champions to explore. Thanks for watching, and keep looking up.